Hello viewers, you are welcome once again. We are still under logic. We are going to treat contradiction. Let's write the topic. Contradiction. Very good. Then, what is contradiction? Contradiction is opposite of tautology. Then we write the meaning of contradiction in logic. Contradiction. We said that contradiction is a statement form that is always evaluated to be true, for each possible combination of truth values of these simple statements that constitutes the statement form. It means the statement form is it means that the truth valuations of the statement form is false. This is false, sorry. It is false. Yes, we said that contradiction is a statement form that's always related to be false for each possible combination of truth values of the simple statements of the simple is a statement form that's always related to be false for each possible combination of truth values of simple statements that constitute the statement form. That means that when a statement form is evaluated to be false for each possible combination of truth value of the simple statement. That means whenever each simple statement truth value they are being evaluated, the statement will be false. That means the truth valuation of the statement is false. There's nothing like truth in the truth valuation of the statement form. It's always false. That's what's meant by contradiction. So we're going to use example, or before then we have two ways or two methods we can use to prove a statement is contradiction. We say there are two methods that can be used to prove a statement form to be contradiction. That means you have two methods that can be used to prove a statement form to be contradiction. One is truth table. Two is assumption of a truth valuation. Assumption of a truth valuation. Assumption of a truth valuation. Now there are two methods that can be used to prove a statement form to be contradiction. One is truth table. Two is assumption of a truth valuation. Now let's use example to elicit or to show what we mean by contradiction. Example, use truth table to prove that P and Q or Q and R implies not or and not Q is a contradiction. You say use the table to prove that P and Q, or Q and R and not Q, is a contradiction. Now, we know that this thing now, this statement form is in restored parentheses. So there's no need to restore the parentheses. We write the statement down. We write P and Q, or Q and R and not Q. We want to use two tables to prove that this statement is contradiction. Now we're going to use what we call abbreviated truth table. We have learned how to use abbreviated truth table. So we're going to make use of abbreviated truth table to prove that this is contradiction. Now, if you remove outer brackets, you know that this and connective, that means conjunctive, connective is what combine these statements, this one and this one, as statement form. That is the main or the prime connective or principal connective is this conjunctive is the principal connective here, because after the outer bracket you get this connective that combine these two statements as a statement form. That means you can see the bracket, remove it. You know that this one and this one, they are being defined by this bracket, and this one is defined by this and this. This bracket defined by this one and this one. So you know that. But before then, how many simple statements do we have that are involved in this statement? You know that we have P, Q, P1, Q2. Q, I already can take it, R3, and not Q. You have Q already. So not Q is the negation of this Q. So you have three simple statements that are involved in this statement form. You know how to determine our truth value combination and how we can combine our truth values of simple statements. We have our numbers. We have 1, 0, 1, 2, 3, 4, 5, 6, 100, 1,000, 10,000, 1 million, 1 billion, trillion, quadrillion, centillion, so on and so forth. So, but anyone that involves 0 and a 1, or only 0 or 1, 1, we are going to pick them one after the other until we get to the required number of the truth value combinations we need. Like here we have 3. We know that to get the number of truth combination of truth value we need, we are going to use our formula 2 power n, where n denotes the number of simple statements that involved in the statement form. So we're going to be 2 power 3. 2 power 3 will give us 8. So we have 8 ways we can combine our truth values of the simple statement in this statement form. So we have 1, we have 0, we have 1, we have 10, we have 11, we have 100, we have 101, we have 110, we have 111. If we count it, we know that it's up to 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it is 8. We see that how it is one after the other in the preceding order. You know that after 0 we get 1, after 1 10, and the number that is involved 0 and 1, or only 1 or only zeros. No, after 0 we get to 1, after 1 10, after 10 11, after 11 100, after 100 101, after 101 110, after 110 you have 111. That is the numbers that involves 0 and the 1 in preceding order. Start counting from 0. So this is how we're going to combine our truth values for simple statements. But note that here we have only but one digit, that means only 0, 1 0, which represents our only one simple statement. What we do so that we have the number that represents, or the values that represent our simple statement throughout. I'm going to add 2 zeros before the 0. Then we have also 1 here. It's only 1 digit. I'm going to add another 2 zeros to make it up to 3. Here you have 10. You have only 2 digits. I'm going to add only 1 to make it 10. Here you have 2. You have to add 1 zero again to make it 3. So we have now 3 digits now in all, so that it can represent our simple statements. So we proceed. We know that we can start from lowest to highest, but we are going to start from highest to lowest. And anywhere we see 0, it will be subtracted with the F. Anywhere we have 1, it will be subtracted with T. So here we have 1, 1, 1. That is going to have T, T, T. So the first one is T. Second one is T. That means P is T, Q is T, then R is T. Then another one we have 110. That means P is T, Q is T, R is F. Third one, I have 101. That means T, P is T, Q is T, R is T, P is T, you have 101. That means P is T, Q is F, then R is T. They have 100, that means P is T, Q is F, R is F. They have 11, that means 0, 11. That means P is F, Q is T, then R is T. Next one is 10, that means 0, 10. That means P is F, then Q is T, then R is F. Another one is 1, 1. That means 0, 0, 1. That means P is F, Q is F, then R is T. The last one is 0, 0. That means F, F, F throughout. That means P is F, Q is F, then R is F. Then copy it to other statements. Here, Q. I'm going to copy these truth values for Q under this Q. We have T, T, F, T, T, F, F, T, T, F, F. Then you're going to negate this Q, because here you have not Q. So anywhere it is T, here it's going to be F here. If it is F here, it's going to be T. So here you have T, that means F. Here you have T, F. Here you have F, it will be T. Here you have F, it will be T. Here you have T, it will be F. Here you have T, it will be F. Here you have F, it will be T. Here you have F, it will be T. That is that. We have. Now let us evaluate this statement. This statement, let us evaluate it. Sorry, before then, sorry, you write, repeat it, this one under this Q, sorry, repeat these values of Q to also this Q. You have T, before we negate it, you have T, T, F, F, T, T, F, F. Then under not connective, you are going to write the negation. That means anywhere it is T, it will be F. So here it will be F, F, T, T, F, F, T, T. Then we know that P and Q, that means the only way we can evaluate conjunctive statement to be truth is when the conjuncts are truth. That means all the conjuncts, they are true. And how many they are, whether there are 2 or 3, but so far it is conjunctive statement, so it's going to be all the conjuncts must be true. So here you have T, so it is T. So it is T. You have T, it is T. TF, no. TF, no. FT, no. FT, no. FF, no. FF, no. So the rest, they're going to be false. So here is false, 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 here is false. Here we have P and R. So the two conjuncts Q and R, they must be truth before it can be validated to be truth, because it's a conjunctive statement. Here we have TT, so it is true. FT, no. FT, sorry. TT, true. TF, no. FT, no. FF, no. TT, true. TF, no. FT, no. FF, no. So the rest, they are false. False, 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 false. Now, having known that, we know that this statement and this statement, they are being combined by this or. You can see their parentheses, their bracket here. This bracket that bind them, it define them. So this or is what combine this statement and this statement. So we're going to evaluate it, and we say that we are going to evaluate all statements, that means the disjunctive statement, to be false if both the disjuncts are false. That means the disjuncts of the statement, they are false. That means to say that if this statement is false, this one is false. We're going to evaluate it to be false. So here you have T, no. You have T, you have F, no. F, yes, it is false here. Here is FF, it is false here. Here is FT, no. FF, yes, it is F here. FF here, it is F here. F, it is F here. Sorry, it is O. Sorry, it is O. It's when you have FF, is F. So here it will be true because it's FT. Here is FF. So it's F here. Here is FF, is F here. Here is FF, is F here. So here is FT, it is T here. Here is TT, it is T here. So it is when you have F, 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 F. So you have now validated this one. Let us go to the main connective. Here, this statement, this connective combine this statement and this statement. So we are looking under not connective now, and this all connective to evaluate this and statement, this connective statement. Now say you are going to have true whenever the conjunctions they are true. But here we have T, we have F, so it is false. Here you have T, you have F, it is false. You have F, you have T, it is false. You have F, you have T, it is false. You have T, you have F, it is false. You have F, you have F, it is false. You have F, you have T, it is false. You have F, you have T, it is false. So it is throughout false. So you have F, 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 F. So we can see that he have proved that this statement is a contradiction. It's a contradict statement. That means there's no mixture of truth throughout. They are all false. You can see the valuation here. You can see the truth valuation that it is F, 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 F throughout under the main connective, and so it is contradiction. Therefore, the statement form is contradiction. So the statement form is contradiction based on our valuation. So let's go to assumption of a truth valuation method. Now use assertion of a truth valuation to prove that these statements are P and Q, or P and Q, or Q and R and not Q is a contradiction. Now, since we know that we want to prove that it is a contradiction, and it can never be truth if it is contradiction, so we're going to assume that this is a truth. Now, what can make this and connective? It means that for this statement to be true, the conjuncts must be true. You see that this is first conjunct, this is second conjunct. So two of them must be true. So we assume that it is true, but we know that it cannot be true. So if it is contradiction, so we assume that it is true. We write it here. write it true, that means that is true, it means that this one will be true, this one will be true. That means this one will be true, this relative here will be true, this relative here will be true. You call this one line 1, line 2. Now, if this one is true, it means that if this one is true, it means that Q is false. If not Q is true, it means that Q is false. Then here we have Q and R. So that means, and this statement should be true. That means this one should be, and this one is true, this one is true, or this one is true, this one is false, this one is false. But let's assume that it is true, this one is true, this one is true. That means this is true statement, this also should be true. So that this one will be true. That is line 3. Now, if in line 4, P and D, Q to be true, that means P should be true, Q also should be true. This must be true. In this Q and R to be true, it means that Q should be true and R should be true. Now let us check whether there is contradiction. Let's check whether this one is line 5. Here we say that Q here, not Q is true. That means Q should be F. Here Q is F here, then but Q is true here. To make this statement true, Q is true. That means Q assigned to truth and a false. Here also Q is true. Q is true, but Q is false here. That means Q is assigned to true and a false. To make this statement to be true. So if that is the case, and now if I assume that here is false, and Q is false here, and R is true here, that means this one will be false. We agreed, yes. But this one can also be true. And if to be true, P must be true, and Q must be true. But Q is false. That is also false. And which means false or false will give us false. So in any way, it is contradiction. Whether if you use this yardstick that here is F, and this Q is F here, and this Q here is true, that means we assign truth and falsity to one statement, which is wrong. You can never assign truth and the false to a particular statement, either true or false, not both of them. But here there is false, here there is truth. So there is contradiction. And if you say that, let us assume that this one is false, that means Q is false, R is true, or R is false, that means it is still false. Very good. If this one is true, it will agree. But here, T is false, T is false, P is true, that means this is false. I'm going to have false and false or false, which we make this present to be false. So in any way, we are going to forget it to be false. So we say that there is contradiction in line 2, this line 2, and line 5, where Q are where Q assigned truth and falsity. It means contradiction. Therefore, the statement is contradiction. So we see that in line 2, we have false assigned truth, and the false truth where it is assigned false, and the truth respectively, one after another. It means contradiction. That means in line 2 and line 5, we can see that Q assigned to where Q assigned to false, and truth and the truth respectively. That means in line 2, Q assigned to false, and line 4 assigned to truth respectively. It means contradiction. So therefore the statement is contradiction. So here we are going to draw our content. Thank you, viewers.